Hello.
Hi,
Hi. How are you doing?
I'm good. How are you?
I'm doing all right.
That's good. Thanks for joining me today.
No, absolutely.
Yeah. Okay, so we'll get started. I'm going to introduce myself first, and then you can introduce yourself.
Yep.
So, I'm Ivanka. I'm really passionate about climate change and sustainability. I'm a high school student. So I did a research. I've been doing research in this field for the past 3 years, and I'm really interested in reducing methane emissions from livestock, especially. That's what my research is in. So I started this initiative, Methane Matters, to educate people about methane emissions and their impact and mitigation strategies. And this is my third podcast in this series where I interview prominent people in this space. And I'm really excited to have you today.
No, thank you, Ivanka. My name is Ratul. I'm an assistant professor at Iowa State University in the Department of Chemical and Biological Engineering, and so pretty happy to be here. So my lab largely looks at building computational models to understand what causes the production of methane and how do we design inhibitors that would sort of prevent this methane from coming out.
Yeah, that's really cool. I'm really excited to learn about that. So my first question is, can you tell us about your background and like your education path?
Oh yeah, sure. So I did my undergraduate education in India. So I'm from the eastern part of India, from Calcutta. So I did my undergrad in Jadavpur University in chemical engineering department, and then after graduating from there, I did my PhD. I moved to the US and I did my PhD at Penn State again in the chemical and biological engineering. But my work was largely on optimization and mathematical models, understanding proteins, largely proteins or biomolecules that are essential for life. So that was the idea. And then after finishing up, I did my postdoc at Harvard Medical School for 2.5 years, and there I was looking at human health type of applications, like how to understand, for example, pain and cancer drugs work in the body. So when you take a pain medication or a cancer medication, what happens to the molecule? How does the molecule navigate into the body? What other molecule does it interact with? And how do you explain efficacy using those kind of models? Again, so that being said, with prior experience in human health, I started my uh, own research lab at Iowa State in 2022. And the idea was to essentially pivot in a way that we use the sophisticated tools that have been developed for human health to apply towards animal health, right? So Iowa State is a big agricultural school. We've got tons of data that gets generated. Lots of studies on animals keep happening all the time. But there is always a need for analyzing the data, making head or tail out of what it means. Can we prevent the next, the zoonotic virus from outbreaking? So there are a lot of these applications which can be benefited from tools that are from the human health domain already, because these are similar systems. So that's what I do right now in my lab, try to understand and benefit animal health.
Yeah. So can you tell us about how you got interested in livestock?
Oh yeah, sure. So I mean, so largely because there is an opportunity. The opportunity here is that human health provides you a lot of tool sets. So again, this is the same answer. So it provides you a lot of tool sets to tackle or understand different stages of diseases in human health. The question is that the same kind of issues or like analogous issues happen in animals as well. But since the animal schools are largely busy in terms of generating a lot of data, understanding what's going on with the animals by doing large farm-based trials, so there's always a need for analyzing that data. And Iowa State being such an university where we have a lot of these experiments going on all the time, so that was some sort of a career switch, sort of, I felt, where I could contribute to animal health. And animal health, there's no extra motivation for animal health besides, if I'm from India, essentially we're surrounded by a lot of different species of animals, and there is a similar kind of stuff that's happening in Iowa. largely has like houses, is home to more than 1,500 species, including birds and animals altogether. So to understand how diseases and stuff would spread from different species to each other and ultimately to humans, it creates this overall paradigm of what is called One Health, like, animal health plus human health together. So this One Health aspect is very, very enticing for me, because there's so much unknowns and every year things are changing. So yeah, if you build tools that generalize enough, then you can sort of help the state first as well as a nation in a very strong way.
Yeah, that makes sense. And that's really exciting that that's possible. So can you tell me about your lab and who all works with you?
So my lab is so we started the lab, as we said, 2.5 years back, roughly 3 years now, and we've grown so far. I think we have different types of members in the lab. We have PhD students, several, like 7 or 8 PhD students at the moment, who are a mix of two different types of people. Some people are very good in computing, who have some amount of knowledge about bio, so that they can handle the projects, but they're not the most strong experts in bio. And then there's a flip group, where basically they are very strong experts in bio. They have moderate exposure to computing. And these two types of people work together to sort of make sure whatever we are doing is not just a computational artifact. It is also grounded in biological reality. So that's the type of our grad students. And we have postdocs also, a couple of postdocs in my lab. They are computational chemists. Essentially, they can build simulations to understand each of these biological processes, and they work together with the grad students. And besides that, I work with a very, very talented group of undergraduate students over here. There are several undergraduate students who work on a continual basis in my lab, and these include mostly coders and software developers and Web3 developers, who are actually essentially whatever tools we make, they actually help to put those tools out in the open, put it on a website, so that others from the research community can use these tools, etc. Because otherwise, as these fields are going ahead, they pick up a lot of pace, and at some point it becomes very esoteric for an experimental group to actually test out something computationally, because the computational tools have become more and more complicated. You require GPUs and machine learning, all of these things. So ultimately, it's not expected that an experimental group who's doing the experiments, they will also have to learn of the compute. So for them to quickly check something and make some analysis, if you put those tools on the website, on a web server, then it's easy for them to go to a website, click and upload things, and see what the results are.
Yeah, that sounds like a good team.
Mhm.
Okay, so what kind of projects are you doing?
Sure. Yeah. So I think yeah, you probably know a little bit about this. So through I met Ashish at the State of Science Summit at UC Davis, and he knows a little bit about my work. The primary aspect of work on the ag side we are doing includes two things. One is surveillance, and the other is intervention. So essentially, when there is a virus, there are specific types of viruses which infect the pig population over here. This is called PRRSV. So Iowa State actually has information about last 14 years of this viral evolution. Like, what has this virus done over the last 14 years? How has it like mutated itself? So we try to learn that, evolutionary tree of viruses that information we get from the university, and try to predict how the virus is supposed to change over the course of the next few years, so that we can make antidotes like antibodies ahead of time, vaccines ahead of time, because we know that this is the expected trajectory of the viral evolution. So that's the type of work that is happening on one end. This is under the surveillance side, and on the intervention side, is basically we're looking at how to tackle different problems that are related to livestock. One is on the vaccine side, as I was saying, and the other is this methane type of projects, where you have this issue that there's a lot of production of methane from the cows, but at the same time, whatever molecules exist in the market, they are either carcinogenic or not very effective. I mean, even if they're effective, they're not very adoptable. People haven't really adopted them as a feed additive to feed the cows very much across the globe. So that's where we wanted to basically step in and say that how do we make sure that we start with a molecule that first increases the overall health of the cow, overall digestive health of the cow, and that molecule should serve as a dual purpose on top of being health inducing, to reduce methane. So a molecule that has two objectives: improving the overall gut health of the cow, plus at the same time reducing methane. That's what we're working on.
Hmm. Yeah, that sounds exciting. Okay, so you talked a little bit about this before, but how are you using technologies like artificial intelligence and machine learning to further your research?
Yeah. So I mean, there are areas where, so with biology, artificial intelligence and machine learning, one has to be kind of careful because there is inherent uncertainty in biology, and which is what defines biology. For example, if let's say two people, they get sick because of the same flu on the same day, you give them the same medicine, they will not necessarily get back up on their feet on the exact same day. So there is variability. So the variability is at the individual level, there is variability at the species level, there is variability at the community level also. So just being aware of the fact that biological systems have variability helps us identify what spaces in biological sciences can machine learning be used without introducing without introducing too much confusion, in a way that let's say what we largely do is we will look at set of biological molecules which are already safe for human consumption, and now we use machine learning and AI to figure out which of them could be useful for mitigating methane. Like, first of all, we start with a set of safe molecules that are largely, let's say, FDA approved and stuff, and just try to use AI to figure out what could be tiny modifications you could perform on this molecule, that they are now endowed with new properties such that mitigation of methane or improving overall cow's digestive health. So machine learning helps us improve the design of molecules, and helps us test them at least within a computer, and then helps us rank them so as to make suggestions. So I can tell my experimental folks to say that, okay, take these top 5, take these top 6, and try this out and see. And again, machine learning plays another role where, there's something called reinforcement learning. So where you take this top suggestions and give it to the experimentalist, and if they say that, hey, the top 2 worked but the bottom 4 did not work at all, they were like wrong suggestions, so both the right answers and wrong answers come back to the model, and the model learns, oh, I should steer clear from these kind of solutions next time, they didn't work. And the top ones that worked, they're like, oh, okay, I learned that they worked, so I have to make sure my next answers are definitely not inclusive of things that are of the bottom 4, but are more inclusive of the things that are of the top 2. So it sort of learns from what was correct and what was wrong, in a way.
Yeah, that's interesting.
Mhm.
Okay, so I have one last question. What advice do you have for high schoolers like me who are interested in stuff like this?
Yeah, I personally feel that there is no, it is never too early to get started with whatever excites you. I think if there is methane mitigation is something that excites you, I think one thing would be good to read as much literature as possible. I think these days, I would say, is sort of we have a lot of tools for reading papers which are even complicated. For example, there is chat gpt and other type of query chat based tools, right, where you can actually paste a specific paragraph from a paper which you find very confusing and you have no idea they're talking about very technical terms. Ask ChatGPT to explain it back to you, right? So in a way, that way you can actually parse very, very complex manuscripts or articles, research articles, which are probably written by people who are much senior than you, but you can sort of self-tutor yourself in learning what they're talking about in simple layman terms. You might from time to time want to check with some specialists like you do, I think your dad is also one of the people who will be able to help you with this, and just check, like, I learned this, is this correct, or am I getting something wrong? So once, that's again another way of reinforcement learning, and you sort of teach yourself and get it validated whether this is correct or not once in a while. And then on the whole, you'll start getting a grasp of what people are doing in this area. And more you do that, I would feel that by the time you're going for an undergraduate degree, you already have some sort of a bent of mind as to, this is the aspect that sort of excites me the most. Let me try and do some research for credit in some lab to see that if that's still exciting for me. um, uh, don't be afraid to pivot, I would say, for high school students. If you're interested in biology and then you come across some prof in mathematics who is interested in working with you, just give it a shot. Maybe that will change a lot of things. Maybe you can always bring in concepts and knowledge that you gain from any experience to anything that you do. There is nothing that's really unrelated. There is nothing that's a waste of time. So that's what I would say.
That's helpful. Thanks. Okay, so that's all the questions I had. Yeah,
Okay.
thanks for joining me. It was fun.
All right.